Welcome to Spaceverse, your portal to cosmic adventures. What if the universe isn't the smooth, balanced place we've always imagined? The James Webb Space Telescope isn't just giving us prettier pictures of space, it's shaking up what we thought we knew about the universe. When scientists studied how far away galaxies spin, they found something strange. Most of them seem to rotate in the same direction. That's not what's supposed to happen. In a universe that's isotropic, meaning it's the same in every direction, galaxy spins should be random. Like flipping a coin over and over, you'd expect about half to spin one way and half the other. But JWST's deep look into the early universe shows a clear imbalance. This suggests that something bigger, something hidden, might be at work, some kind of cosmic alignment that shapes the universe on a massive scale. And here's where it gets wild. What if that alignment is the leftover spin from a black hole? Not just any black hole, what if our whole universe is actually inside one? In that case, the spin of that black hole could have been passed on to our universe itself, giving many galaxies the same rotation. If this turns out to be true, it wouldn't just change a few science books, it would completely rewrite our idea of how the universe began and what it really is. The James Webb Space Telescope was built to look back over 13 billion years into the past, letting us see galaxies as they were in the universe's very first moments after the Big Bang, like opening a time capsule from the dawn of everything. In one study led by Lear Shamir of Kansas State University, scientists examined 263 galaxies that formed only about 300 million years after the Big Bang, when the universe was still in its infancy. These galaxies are among the oldest cosmic structures ever observed, offering a rare glimpse into a time when the first stars and galaxies were just beginning to take shape. And here's where it gets weird. About 60% of those galaxies are spinning clockwise, while only 40% spin the other way. That might not sound like much, but in a perfectly balanced, directionless universe, those numbers should be closer to 50 by 50. This isn't the first time astronomers have noticed something like this. The Hubble Space Telescope picked up similar patterns years ago, but those surveys were smaller and easier to dismiss as coincidence. Now JWST's sharper, deeper images make the bias harder to ignore. And that bias matters a lot. According to the standard model of cosmology, the universe shouldn't favor one direction of spin over another. Rotations should randomize over time. But if this directional preference really existed in the early universe, it could mean that space itself was born with a kind of built-in twist, a cosmic handedness that shaped the way galaxies formed. That leads to some massive questions. Could there be a cosmic axis, a hidden structure threading through the universe? What could have created it? And what does it say about the true nature and origin of everything? If confirmed, this finding would shake one of the foundations of cosmology, the idea that, on the largest scales, the universe is the same everywhere and in every direction. Instead, it might be telling us that the universe has a deeper, more mysterious structure baked into its earliest moments. One of the most fascinating explanations for this strange spin pattern comes from an idea that's been floating around for decades: black hole cosmology. This model suggests that our universe might actually be sitting inside the event horizon of a gigantic black hole in some much larger parent universe. In this scenario, the Big Bang wasn't the one-time birth of everything. Instead, it was more like a bounce. Imagine matter collapsing inward under the crushing pull of gravity, reaching an unimaginably dense state, and then, thanks to exotic quantum and relativistic effects, rebounding into an entirely new expanding spacetime. So how does this tie into the galaxy spin mystery? If our universe began inside a rotating black hole, its spin could have been imprinted onto the very fabric of space. That cosmic hand-me-down might explain why early galaxies seem to favor one direction of rotation, a faint but telling fingerprint of the black hole that birthed us. This isn't just wild speculation. Physicists like Nico Poplovsky have explored how a twist on Einstein's theory, called Einstein-Cartan gravity, allows for matter to carry spin, preventing black holes from collapsing into true singularities. Instead, the collapse halts at an ultra-dense point, then rebounds, giving rise to a brand new universe. And here's where it gets even more interesting. This idea could help explain several other cosmic puzzles. The Hubble tension, the stubborn disagreement over how fast the universe is expanding, might be easier to resolve if our expansion history isn't what the standard Big Bang model predicts. JWST's discovery of impossible galaxies, mature, massive galaxies shockingly early in cosmic history, could also make sense if our universe inherited structure or matter from a pre-bounce phase, jump-starting galaxy formation. In other words, this theory weaves together multiple mysteries: the spin bias, the early massive galaxies, and even large-scale cosmic alignments, all under one bold framework. If true, it would change everything. The Big Bang wouldn't be the ultimate beginning, it would be a handoff from the death of one universe to the birth of another. Black holes wouldn't be dead ends in space, they'd be cosmic wombs, gateways to new realms with their own unique physics. Of course, this is still far from proven. The current results are based on just 263 galaxies, a solid first step, but nowhere near enough for a cosmic verdict. We'd need to study thousands more galaxies across many different parts of the sky to confirm whether this spin preference is truly universal. We also have to rule out the possibility that it's all an observational trick. Maybe our position in the Milky Way or the way JWST captures light from distant galaxies is skewing the results. These are questions that astronomers are now eager to test. So, what comes next? The next step is all about scale and precision. Expanded surveys are on the horizon. JWST will keep pushing deeper into the cosmos, capturing thousands more early galaxies to see if this strange spin bias shows up everywhere. Searching for relics will also be key. Astronomers will hunt for primordial black holes or other cosmic leftovers that could hint at a bounce universe, evidence that our cosmos might have sprung from the collapse of another. And then there's revisiting the numbers. Cosmologists may need to recheck our measurements of distance and expansion rates, something that could even help solve long-standing puzzles like the Hubble tension. Whether or not the black hole universe theory survives, one thing is certain: JWST's data is already changing the way we see everything. It's forcing scientists to question some of the bedrock assumptions of cosmology and opening the door to ideas that once sounded almost too wild to consider. Could our universe really be inside a black hole? We don't have the final answer yet. But with galaxies showing a shared spin direction, possibly a cosmic inheritance from such a black hole, it's a question that now demands attention. As JWST keeps watching and the data keeps coming, we may soon find out whether this pattern is just a statistical fluke, or the first real clue to a hidden architecture shaping our universe from its very birth. And that's it. Galaxies spinning in sync, whispers of a black hole universe. Every answer sparks a bigger mystery. This is Spaceverse, where we explore the cosmos beyond imagination. Until next time, keep looking up.